Welcome to the Slop Farm. Enjoy the video.
You start by gathering the accelerometer, a microcontroller, buzzer, stable power source, and a few passive parts. These are non-negotiable. First, mount the accelerometer to a rigid board to get clean motion data and prevent false triggers. Then wire VCC and G&D securely and connect data lines, SDA/SCL or SPI, to the microcontroller. Make sure grounds are common. Once done, add a pull-up or series resistor, where recommended, and check voltage levels with a meter before powering up. You now program the microcontroller to sample at 100 to 200 Hz, so you capture seismic frequencies. This preserves small P-wave signals. Implement a simple bandpass or high-pass filter in code and compute RMS or short-term average versus long-term average to detect sudden energy increases. That detects true shakes versus drift. Once done, add debounce and hysteresis to avoid chatter. Make sure to log samples to serial while you adjust thresholds and confirm the algorithm flags shakes without false alarms. Finish by building a protective enclosure and securing the sensor to the mounting plate. This prevents spurious motion and weather damage. Power the unit with battery backup or UPS to survive outages and connect the buzzer and any network notifier. Then run systematic tests. Calibrated taps, controlled shakes, and replayed waveform data to validate timing and sensitivity. If something goes wrong, check for ground loops, sensor clipping or saturation, and inconsistent sampling intervals. Fix wiring, lower gain, or increase sample stability to resolve errors.
Thanks for watching. Consider subscribing if we helped you today.